Okay, so here are some density problems. So the first thing you'll need is a calculator, and we'll also need to review our formula, which is density equals mass over volume. You can put density over 1 if you'd like. Also, something that is important to realize is we need consistent units. So for example, if the density is in grams per milliliter, we need our volume to be in milliliters, we need our mass to be in grams, etc. So for example, I see that in number 1 already. So what is the volume of a tank that can hold 18,754 kilograms of methanol whose density is 0.788 grams per milliliter? So I need to first adjust this. Notice how my density is in grams per milliliter. So I need to change my kilograms to grams. So over here, whoops, I'll do 18,754. Now you don't need to do this way, but remember dimensional analysis. There's 1 kilogram, there's 1,000 grams. So we have to multiply by 1,000. So we have 18754,000 grams. So that's our mass. So density is 0.788 over 1 equals 18754,000 over V or X, which means you're going to multiply these. Here, let me change the color for a second. So remember, cross multiplication, you're going to multiply those, and then it's going to be equal to those. So I'm going to erase over here, just so I have some room. So 0.788 times x equals 18754,000. So divide both sides by 0.788. So let me plug it into my calculator. 18754,000 divided by 0.788. So I get 237,941.62. Okay, so let's talk about sig figs. This number right here has 5 sig figs, and this has 3. So our final answer should have 3 sig figs. 1, 2, 3. The 9 would round the 7 up to 2, 3, 8, and then 1, 2, 3, 4. 1, 2, 3, 4. So that's 2,380,000, and that is milliliters. Yikes, that is a lot. Okay, what is the density of a substance whose dimensions are such and whose mass is that? Okay, so the first thing we need to know is that volume is length times width times height, which hopefully you did know. So we need to multiply those 3 together. So 5.54 times 10.6 times 199. And I have a big number, and we're going to round it to 3 sig figs already. So I'm going to say 11700, because it was 11,686, so it's 11,700 cubic centimeters. Okay, now I need to find density. I'll change my color. So density equals mass, which is 28.6, over volume, which is 11,700. 28.6. Come on, 28.6 divided by 11,700 is, now I want 3 sig figs again, so 0.00 stays, 2, and it's 4 repeating, so I'm just going to do that. And that's going to be units of kilograms per cubic centimeters. Okay? And by the way, if I make any mistakes and you think it's different, like, you have something different than me, that very well could be, I'm doing this quickly on the fly. So we're looking for mass. So density is 2.50, put it over 1 grams per milliliter. Okay, so already I see a difference in units. There's milliliters here and here's liters here. So to go from liters to milliliters, we're going to multiply by 1,000. So it would be 15,000 milliliters. Technically, we'd have to keep the sig figs. So we're looking for mass, and we have 15,000 sig figs. So 2.50 times 15,000 is 37,500, and that is grams. And yeah, okay. In the Macy's Thanksgiving Day Parade, there was a new float, the Cheerios B. I don't know how old this is. The jar of honey it was holding contained 36,763 liters of helium. If the density of helium is that, what is the mass in the jar in kilograms? Okay, so first thing we have to do is change liters to milliliters because our volume is in, our density is in grams per milliliters. So we'll do, here's our density, 78, put it over 1. We're looking for mass. And so we're going to take this volume in liters and we're going to make it milliliters by multiplying it by 1,000, 36,763,000. So plugging that into my calculator, 36,763,000 times 0.000178. These numbers are ridiculous. So the mass is 6543.814. That is grams. And now I need to go to kilograms, which means divide by 1,000. So 6.543814, which is way too many sig figs. So if I have 5 here and 3 here, 0.654. Or excuse me, 6.54. That would be kilograms. Okay. If sig figs are tripping you up, that's okay. You know, I hope the main concept of density you're getting. My gas tank of my car is a total volume of 68 liters. If 5 liters of gas is a mass of 450 kilograms, what is the mass of gas in my tank? What is the density? So we can do a proportion here. So we have 5 liters over 450 kilograms equals 68 over, I don't know. So we'll do cross multiply, which is 5x equals 450 times 68, which is 30,600, divided by 5. X equals 6,120, which really should be one sig fig 6,000 kilograms, 6,000 kilograms. And then what is the density of my car's gas? So I would just flip it. Let's see. So density is mass 450 over volume. Well, actually, so it should work, but I'll use this one. So 6,000 kilograms over 68. 6,000 over 68 gives me 88. We need 2 sig figs. 88 kilograms per liter would be my density. By the way, if I make any mistakes, let me know. The density of paper is such. What is the mass of the paper? And it looks like we need to do some volume. So volume would be 76, which is thickness or height, times 215.9 times 2. So hold on a second. 76 times, I think I plugged it in wrong. 215.9 times, no, 279.4. Okay, this is absolutely ridiculous. So 4584506.96. That is before rounding to sig figs, which should be 244. I need 2 sig figs. That would be millimeters cubed. So if I was to go to 2 sig figs, 4, 6, that rounds that up, 0, 0, 0, 0, 0. That is 4,600,000 millimeters cubed is our volume. Density is 12 over 1 equals mass over 4,600,000. So 12 times that crazy number gives me 552 0.20000, which does indeed have 3 sig. Oh, we need 2 sig figs, so we're going to make that a 0 here, and this is going to be in grams. 55 million grams. Yikes. Okay. In pottery class, you throw a pot from a lump of wet clay. Your pot's mass is 5.5 kilograms. After the pot is fired, its mass is 4.9. The density of wet clay. What is the volume of your pot before it's fired and then after? Of course, sig figs. So density, no, we want volume. So wet is 1.60 over 1. And the mass before is 5.5 over volume. Let's set this one over here. So fired clay is 1.36 over 1. And then after you fire it, it's 4.9. Oh, no. Look at that. This is in grams and this is in kilograms. So I actually have to change this to 5,500 and 4,900 grams. This is volume. Okay, so this would be cross multiply 1.6 times the volume equals that. So 1.6 x 5,500. Divide both sides by 1.6. So 5500 divided by 1.6. 3. Now I need 2 sig figs. So 3400. And that is what? Cubic centimeters. So this is going to be 1.36 V equals 4,900. 1.36 4,900 divided by 1.36. And again, we want 2 sig figs, 3600. Okay. The volume of an aquarium is 1890 liters. Volume density of seawater is such. Okay, so I need to change this to 1,890,000. So there's that change into milliliters. So the mass. So 1.03 grams per milliliter is here. It's our mass. We're looking for 1,890,000. So we got to multiply those two things together. 1.03 times 1,890,000. So our mass is 1,946,700. But sig figs, we need 3. So 194. Oh, nope. That gets changed up. So this 6 rounds that up to 195,000. We need to hold our place values, and that's going to be grams. Okay, I got to tell you, this is way harder than any density problem you're going to have to do ever, because there's so many. There's sig figs, there's conversions, but the actual formula for density is pretty darn easy, hopefully. And hopefully it didn't get lost in here. If you have any questions, please let me know. Thanks.